Hi, welcome back. So in the last session, I have mentioned that the pass-one algorithm of the linking loader, how it works, and we'll move on to the pass-two algorithm. Therein, the linking loader process the text record and modification record to perform the actual loading, relocation, and linking. So the process of loader and linker is to perform loading, linking, and relocation. So same thing which will be happening over here in the past. That's the actual process of loader and linker happens here. So in order to do that, the linking loader has to process the two record. One is a text record and the other one is a modification record. So we'll see the algorithm, how exactly this works. So as usual, the algorithm start with the begin and ends with the end. And it is taking the value for CSADTR from the program address. As already I have mentioned about the program address, and it takes the value from operating system. The same thing is assigned to the control section address for the first program. And it moves on to the next program. Then based on the value from control section address and the control section length, it takes the value for the next next control section. The next line, what happens here is once the entire process is done, the next step is to execute the program. During the execution of the program, where the program has to start its execution, that is denoted by the end record. So that is stored in the variable called execc_addr. This is the execution address variable. So where the execution has to start its execution. So where the program has to start its execution. So that normally the starting address of the first program. So the program address gives the starting address of the first program, and that has been assigned to the execution address as well. So till the loader reaches the end of the object program, it processes the entire thing, read the next input record, that is the header record, and it sets the value for the CSLTH from the header record. And the record type is not equal to E. It does the same process, begin, read the next input record. Since the linking loader in pass2, it process the text record and the modification record. So why the text record and modification record has to be processed, as we know that in the text record we can get the object code. So the purpose of the loader is to load the program into the memory. So when it loads the program, it is actually loading the object code into the memory. So the object code is present in the text record. So obviously it has to process the text record. And what is the purpose of this modification record is if there is a relocation that is mentioned with the help of the modification record, and also the linking process has to happen. So whenever there is a symbols are used, so which is not defined, then those places the symbol value is not been given. So in such cases, the modification record which contains the information regarding that, so those information has to be processed by the linking loader, for which again we have the modification record that is to be processed. So now if the record type is equal to T, so if it is a text record, begin. If the object code is in the character format, convert into the internal types. This is a normal procedure from the beginning, starting from the absolute loader. Then I have explained about bootstrap loader. So in all those loaders, we have seen that the the character format is converted into internal representation that is to be processed, that can be understood by the machine. So move object code from the record, that is text record, to the location mentioned. So when you see the location, so there it is given CSADDR plus the specified address. So what is the meaning of this one is, so in the text record, so what is the starting address is given, and the length of the object code is given, then followed by the object code. So when the first object code is taken, so that has to be loaded into the proper location. Okay, and the same thing will be followed for the remaining also. So when the first object code is taken, so what is the starting address, which is mentioned in the text record also. But this address, which was considered based on the starting address at the time of assembly. So when the assembler creates the object program, so during that time, what was the address given in the program based on which it has been given. But now, as you could see, at the time of loading the program, so the starting address of the program is totally changed. So the relocation happens. So because of which the same address, whatever which is mentioned in the text record, if you load the object code into that location, then it is totally wrong. So what you have to do is you need to do the changes in the location. That is where what we do is CSADDR plus the specified address. So when you have the address mentioned in the text record plus CSADR. So if the address is mentioned as, say for example, 0054, then with the 0054, the 4000 has to be added. So in 4054, the particular object code has to be stored. So in such way, it has to do the modification. So this is actually the relocation happens here. And once this process is done, see, wherever you see the text record, so this process will be keep on repeating, because as you know, the text record, it's not only one single record. There are plenty of records would be there available based on the number of size of the program. So how many number of instructions you have, based on which the number of text record also keep on increasing. So for whenever there is a text record, so this process has to be repeated, and it has to be done. If suppose the record type is it is a modification record. So what we suppose do is, as you know that, then the modification record, just to recall the example what we have discussed during the time of program linking. There was a label called REF4, and there was a expression for that REF4 was given as NDA minus list A plus list C. Right? So this is the expressions I was keep on telling to remember. This is the one of the expressions we have taken in three cases, that is program A, program B, and program C, in order to understand what is the object code is generated for that particular instruction in all the three places, all the three control sections. So if you could remember that NDA minus list A plus list C, that particular expression. So in program A, so for the NDA minus list A, there was no problem, because we could make out the value for NDA minus list A, but there was no definition for list A in program A. Since there was no definition for the list A, so it was considered 0, and the modification record was generated for that particular expression, particular instruction, we can say. So that has plus list C. So if at all the list C value is known, then that has to be added with the existing value. So which is mentioned in the modification record. So the same modification record is processed by the linking loader now. So when the linking loader sees that modification record, and it is able to get what is the symbol name over there, then it can search the symbol name from the ES tabs. That is what exactly happening here. Searching ES tab for modifying symbol name. So what is the symbol name which is mentioned in the modification record? That symbol we could search from the ES tab. So definitely ES tab will be having those symbol with the value. Correct. So now if it is found, then add or subtract the symbol value. So whatever in the location, that is ESADDR plus specified address. So we can add or subtract. So in our example, whatever I have told you, that example, that's NDA minus list A plus list C. So obviously the list C value has to be added with the existing one. So in the right place, it has to be added. That is why the right location is given as CSADDR plus specified address. I think you remember it was 0054. In that location, it was mentioned. So it has to be 4054 since we add 4000 with the existing address. If the list C is not found in ES tab, obviously it is an undefined symbol. So we can end the process. We reach the end of the record also. If an address is mentioned in the end record, so what is the address is mentioned in the end record, that we can assign in the EXEC ADTR. Okay, so that value can be assigned. So with that value, definitely CSADTR has to be added so that the proper address we can assign into the EXEC So whatever the address specified or mentioned in the end record, that is not the actual address. So to find out the actual address, the CSADTR value has to be added with that. So that value, the resultant value, actual address will be set to the execution address. And then again, we can add the CHLTH to the CSADTR so that it can go to the next control section. So this will be repeated for all the remaining control section. Once everything is done, then we reach the end of the file. All the object programs are done. We reach the end of the program, end of the file as well. Jump to the location which is given in the EXEC ADTR. So what for? To start the execution. So once the loading process is done, relocation is done, the linking is done, so everything is over, and now the program has to start the execution. So where from it has to start the execution, which is given in the execution address. So this is how the loader works, how it processes the entire the functions of relocation, linking, and loading. So these two algorithm, which is given the proper explanation about the how exactly the linking loader works. In order to search the ES tab, normally we use the symbol name for searching the ES tab for any external symbol. Because in the ES tab, we have the symbol with the corresponding address. As you could see in the pass-to algorithm, we were searching not only the pass-to algorithm, even the pass one also we were searching in order to make an entry into the ES tab. So instead of using the name, suppose if we have a option, if we have an option to use or to assign a reference number to each and every symbol, then it will be improving the efficiency of the searching. So the searching will be efficient. In order to make it efficient, we can opt instead of using the symbol name, we can go with the reference number. So the reference number can be used in the modification record also. For example, in the ES tab, we have the program name, that is a control section name, and as well as the symbols. For the control section, we can give the value as 0, 1, and for the remaining, we'll give as 2, 3, and so on. Just I'll show you an example how this is happening. Say if you look at the program A, and it has the corresponding values. Okay, so in program A, what are the symbols are there? So that is used with the numbers 2, 3, 4, 5 like that. And in program B again, the program B is numbered as 1. The remaining symbols list A and A, all those are numbered with 2, 3, 4, and 5, so on. So similarly for the program C also. So whenever there is a control section name, in control section name is given with the number 1, and the remaining symbols are given with the remaining numbers. And if you can see the program, object program, we have refer record, right? We have refer record. So refer record represent that which are the symbols referred from other control section. So we might have used those symbols in our program, but those definitions would be available in other control sections. So we refer these symbols from other control sections. So those symbols are mentioned in the refer record. So if you could see R denotes refer record, and list list B, list C, end C. So these are the values are available. These are the symbols are used in the program. So those are mentioned in the refer record. And if you could see that the names with the number, so 02, 03, 04, 05. So the whatever it is underlined, that is representing the list B, end B, list C, and end C. Now, if you could see modification record, in general, in the modification record, with the flag, we give the symbol name, right? So instead of the symbol name, there are reference numbers. So in place of say list B, list C, and end C, we can see the numbers. So that way, when it is searching in the ES tab also, it is searched based on the numbers instead of the names. So this will be improving the efficiency of searching in the ES tab. The same thing which is mentioned in the different program. This is the program B, and you can see that there are symbols which are referred from other control section like list A, NDA, list C, and NC. And if you could see the modification record also, there are a lot of changes. You can find it out. A lot of variations you can find it out with respect to the symbol name. Instead of symbol names, that is only the reference number. Whatever it is underlined, that shows the reference number. And this is pointing to program C. So this is, if you look at the program, the entire program is not given. In between only the refer record and the defined record is mentioned, not with the entire thing like header record, text record, all the text record is not given. Only very few things are given which is relevant to this concept, which are given. So based on this, we can make out that yes, we have certain methods, certain techniques which can be used so that we'll be able to improve the efficiency while searching the symbol names. So next topic would be machine independent loader feature. So whatever we have discussed is about machine dependent features. In machine dependent features, we were discussing about relocation, program linking, and the linking loader algorithm, how it performs the process of linking, loading, and relocation. with respect to pass 1 and pass 2 algorithm. So this is what about the machine dependent features. What is machine independent feature? What are those? That we will discuss in the next session.